the question in chapter 1 of KMNS trial question year 20 and 21. So we have given information about isotopes, which is Si, which is silicon, and then we get the information over here, here, and over here. Yeah, this is our information that we get. So we need to calculate the relative atomic mass of Si. So first of all, we need to know their mass first. Okay, so their mass is actually we need to sum up this and this. So you need to write the formula first, and then you will need to sum up them over here, which is here and here and here, and then this one will be their abundance, and then you will need to divide with their abundance, and then you will get the value over here. So but this is not the final answer, because this is just the average atomic mass that we get, and then it has unit, but what we want is the relative atomic mass. So if we need to get our relative atomic mass, we need to use our mass of one atom, which is coming from here, and then we need to divide into 1/12 times mass of one atom of carbon 12, and then so we will get an answer of 28.11, and then it has no unit, no unit for this. Okay, so that will be our answer. So proceed to the question B. So we are given that equation over here. So we are given an equation over here. Yeah, and then we have given an information that we have 1 gram of this and then 1 gram of this. Yeah, so they are going to react. So we need to determine which one is the limiting reactant. So we will start from the so we will need to calculate their respective number of mole first. This represents the mole. Okay, so we are going to calculate the mole. Okay, so we have okay, so we have 1 gram of the NaHCO3, right? So we need to, how we can know their mole, so we need to divide with its molar mass, which is 84, and then it is given in the question, but in the last part over here. Okay, so afterwards we will get answer of this, but remember to take it as 4. So remember to take it as 4 dB first. If that is not your final answer, please get the 4 dB, and then remember to write all your formula before you calculate. Okay, and then afterwards, for the number of mole of this, you need to calculate by using the same formula, and then that's also 1 gram, and then divide into its molar mass, and then you will get the answer of this. And then remember, it is 4 dP. And then we will proceed to here, which is we are going to use the information that we get from the equation, that we know that 3 mole of NaHCO3 will react with 1 mole of H3C6H5 and O7. So how many of the we just take one of the value that we get, which is this. Yeah, because this is simple, right? The more simple, because here is 1, so we times on with 0.0052, and then we will get that because if here we need to times with 0.0052, here also we need to times with the same value. So we will get that if we use 0.0052 mole of H3C6H5O7, we will need a value of 0.0156 mole of NaHCO3. Is it clear? So that this one will be the value that we need. But how many we have? The value that we have already calculated over here, which is the value that we calculated is over here. So this one is the value that we calculate that we have, and then this one is what we need. So the need is over here. So we can get a conclusion that if the NaHCO3 that we have is less than we need, so it will be a limiting, because we have the things that we need is more than we have, so it's limiting reagent. So the limiting reagent will be NaHCO3. Okay, proceed to the question of B, and then we will be the second question over here. So the B2. So we need to calculate the mass of carbon dioxide formed. So yeah, the same, we need to write out the equation first for us to take out the information from here. So we know that 3 mole of NaHCO3 will react with 3 mole of CO2. So 3 mole, we make it 1 first. So it will be easier in our further calculation. So we know that we use which one is the limiting. We use the limiting to calculate for our product one. So the limiting reagent is NaHCO3, right? Sorry, okay, NaHCO3 is over here. Yeah, it's our limiting. So how many mole that we have, which is 0.0119. So we can just transfer it over here. We times on 0.0119. Here also the same. We need to times multiply at two same part. Okay, so we will produce a 0. If we use the amount of this, we will produce a amount of 0.0119 mole of carbon dioxide. So how to calculate the mass? To calculate the mass, we just need to simply use our mole and times on with the molar mass, which is 0.0119 mole times on with its molar mass. For C is 12, and then oxygen is 16, but we have 2 times 2 plus on, it will become 44. And then the final answer will be 0.5236 gram. Yeah, that's it. That's our answer. And then we will proceed to how much excess reactant remain. How much excess reactant that remain after the reaction. So what is the excess reactant? So we have known that this one is the limiting. So this will be its excess reactant. So over here, right? So we will get 1, so it will be simple, divide 3 over here, and then we'll use the limiting. Yeah, so limiting is the we need to times on 0.0119, which is the information that we get in the previous, just same as here lah, or you can say it is same as here. Okay, so you times on 0.0119 over here, you will also need to times on 0.0119 over here, and then it will become like this value. And then how we can calculate our excess, right? We need to use that what we have to minus that how many that we need. So that will be baki, there will be a excess one. So after we calculate 0.0052 minus with this value that we take from here, we'll get a 0.00123 mole. Yeah, that's it. That's the excess, but it is in mole. We want it in grams, so we need to calculate the mass. So to calculate the mass is like simply the mole times on the molar mass to get the final answer of 0.237 gram. Question will be a question about like so the concentrated hydrochloric acid is commonly used as a laboratory reagent, and then we need to calculate the mass of HCl contained in 500 ml of a solution, and then we given the density containing 37.2 of HCl by mass, and then the information of the density is 1.19. So the information that we get, we need to list out over here first, so that will be easier for us to see. So the volume of solution that we get is 500 ml, and then the percentage by mass is 37.2%, and then density is 1.19 gram per ml. So first of all, we will need to calculate the density first. So for the density, right, so what is the formula of density? We need to write it out, which is the mass of solution divided to the volume of solution. So over here we need to sub in the value that we get, 1.19, and then over over 500. This one is the in mil, since here is also in gram per mil, right? So these two part will be the same. So so we can get replace it over here, and then you will get a mass of solution of 595 gram. So percentage by mass that we will get is percentage by mass is equal to mass of solute. We need to write out the equation first and then times on 100%. Remember, for this 100%, that's very important because it is in your equation. So the information we already get over here, we can just simply sub inside it, this, and then mass of solute, and then this, the information that we get, we can simply sub inside this, and then we'll get a final answer of mass of solute of 221.34 of gram. Okay, so we proceed to the final question, which is the D part. Okay, so the D part in the experiment displays copper from copper sulfate, or okay, and then filter off that we get an information from here, and then we need to write a balanced chemical equation for the above reaction, right? So zinc was added into an excess of copper 2 sulfate. So added into this added into this, and then it will produce displacement, right? So it will displace the Cu, the Zn will replace the Cu to become ZnSO4, and then we will get a mass after we wash and trade, right, we get a copper, which is over here. So we will know that this is our equation, and then you need to see like their charge, is it the correct one? Because Zn is 2 plus, SO4 is 2 minus, so we don't need to add anything, right? So here is also 2 plus 2 minus, so we didn't need to add anything. So this will be your chemical equation. So okay, so over here we will need to calculate the second part will be calculate the percentage yield. So we know that we have the mole of Zn, which is how we can know it, because we know that we have a 6.5 gram of zinc. So we need to divide into the molar mass of the zinc, so we will get its mole. And then for the mass of so that we know that 1 mole of Zn react with 1 mole. This sign is very important, like react or produce. Yeah, so it will react with 1 mole. It will produce 1 mole of Cu. So when we have 0.09939 mole of, okay, so it will produce the same lah, because here we times on 0.09939, and then here we also need to times on 0.9939. Yeah, so we will get a number of mole. We will get 0.09939 mole of copper. And then so how we can calculate the mass is just simply times the mole and also molar mass. So over here, right, so we will get a final answer of mass, which is 6.3212 gram. And then so to calculate the percentage yield, we need to write out the formula first, and then the 100% is very important. And then after you sub the value, you will get a final answer of 75.93%. So that's all for this question. Thank you.